Today we're going to be speaking about special right triangles. And right now we're looking at a 30, 60, 90 right triangle on the left. And let's say the side opposite the 30-degree angle is 1. The side opposite the 60-degree angle is square root of 3. And by using the Pythagorean theorem, we would certainly figure out that the hypotenuse was 2. On the triangle on the right, it may not be exactly the same size. And so let's say we made it, let's say, about 3 times bigger. So this side wouldn't be 1, of course. It would be, let's say, 3. And this side would be 3 times the corresponding side of the other triangle, or 3 the square root of 3. And the hypotenuse would be 2 times 3, or 6. But these are still similar triangles, which means the corresponding sides are in proportion. So using our trigonometry, we know that the sine of 30 degrees in this first triangle is equal to the opposite side 1 over the hypotenuse 2, or 1/2. If we take this triangle that's 3 times bigger, but it's still 30, 60, 90, we would say that the sine of 30 degrees is equal to the opposite side 3 over the hypotenuse 6. If you notice, it's still 1/2. So because there are similar triangles, the sine of 30 degrees is always going to be a 1/2, no matter how large or how small the triangle, because the corresponding sides are in proportion. So going along with that, in the 30, 60, 90 right triangle, let's deal with a smaller one. We can certainly see that the cosine of 30 degrees, which is the adjacent side over the hypotenuse, would be the square root of 3 over the hypotenuse 2. If we wanted to find the tangent of 30 degrees, it's always the opposite side of the adjacent sides, so it would be 1 over the square root of 3. And so those are the common trig functions for 30 degrees. Now let's deal with it for the 60-degree angle. So for the 60-degree angle, we see that the sine of the 60-degree angle is equal to the opposite side, which is the square root of 3 over the hypotenuse 2. The cosine of 60 degrees would be the adjacent side. In this case, it would be our 1 over the hypotenuse, which is 2. And finally, the tangent of 60 degrees is equal to opposite over adjacent, which would be the square root of 3 over 1, which of course we know is the square root of 3. So these special ratios you do need to know. Let's summarize them. You should know that the sine of 30 degrees is always 1/2. The cosine of 30 degrees is always the square root of 3 over 2, and the tan of 30 is 1 over the square root of 3. Same thing with the tan of 60. You need to know it's square root of 3 over 2. Cosine is 1/2, and the tan of 60 is the square root of 3. The easiest way to memorize this is, let's go back to our original triangle, is to draw a triangle that has a side of 1, a side of square root of 3, opposite the 60-degree angle. The 1 would be opposite the 30, and a hypotenuse of 2, and then you can figure it out all over again. Our second special triangle is a 45, 45, 90 right triangle. A lot of you will recognize that as an isosceles right triangle. And the easiest way to draw that is to make the two equal sides equal to 1. So there's 1 there and 1 there. And using the Pythagorean theorem, you could easily figure out that the hypotenuse will always be the square root of 2. And once again, if we drew another 45, 45 right triangle like this one, let's say we make it 4 times as big, then the current equal sides would be 4 rather than 1, and the hypotenuse would turn out to be 4 times the square root of 2. But notice that the corresponding sides are still in proportion. So for example, if we want to find the sine of 45 degrees in our first triangle, we know that it would be the opposite side, which is 1 over the hypotenuse, the square root of 2. If we look at it in our larger triangle, the sine of 45 would be the opposite side, 4 over 4 the square root of 2. And if you do notice that the 4's will cancel, and you're left with the ratio of 1 over the square root of 2, which is exactly the same as it was in a smaller triangle. So it doesn't matter how large or small the triangles are, they're similar, and therefore those ratios will always be the same. So in this case, the sine of 45 is 1 over the square root of 2. So to continue, the sine of 45 is 1 over the square root of 2. Clearly, if we want to find the cosine of 45 degrees is equal to the adjacent side, which is 1 over the square root of 2. And if we wanted to find the tangent is always the opposite over adjacent, so the tan of 45 would be 1 over 1, which is 1. And so these three relationships is what you need to know and memorize. The easiest way to do it is simply draw a right triangle, an isosceles right triangle, where the two legs are 1, and they're equal, obviously, and the hypotenuse is square root of 2. So to summarize this, in a 45, 45, 90 right triangle, the sine of 45 degrees is always 1 over the square root of 2. The cosine of 45 degrees is also 1 over the square root of 2. And the tan of 45 degrees is equal to 1. And so these are the relationships that you do need to memorize, you need to be able to use. So why don't we do an example? In our first example, we have a triangle where 30, 60, 90. Clearly, if one side is 30, one side is 90, we know that the remaining angle must be 60. We want to find the length of each missing side without using a calculator and no decimals. Basically, what we're saying is we need to find the exact value of each missing side. To help you along, I put the ratios up on the upper right side of the board. So let's see how this works. If we want to find u, we can simply say the sine of 30 degrees is equal to its opposite side over the hypotenuse u. And now we know that the sine of 30 degrees is a half, so we simply say that's equal to a half. So now all we have to do is solve for u from this equation. So all we could do is very simply cross multiply. That would be the easiest thing to do. And we would get u is equal to 4. And that would make sense since we know that the side opposite the 30-degree angle is always half the hypotenuse. So u is now equal to 4. If we want to find the cosine, if we want to find v, there's two ways we could do it. You could certainly use the Pythagorean theorem now to solve for v. What we're going to do is use some trig. So what we want to do is deal with either the 30-degree angle or 60-degree angle. We have two choices here. We could talk about the cosine of 30, which is our v over the hypotenuse, or we talk about the sine of 60, which is also our v over the hypotenuse. Let's do the 60-degree angle. So we can say that the sine of 60-degree angle is equal to its opposite side v over the hypotenuse 4. And we know that the sine of 60 is the square root of 3 over 2. So here we have this. And the easiest thing to do would be to multiply both sides by 4. So if we multiply by 4, these 4's cancel, and we would get v is equal to 4, the square root of 3 over 2, which we can reduce a little bit, and it becomes 2, the square root of 3. Keep in mind, we could just as well have used the cosine. So why don't we do that? If we wanted to use a cosine function, we would have said the cosine of 30 degrees is equal to its adjacent side v over the hypotenuse 4. And when we look things up, we know that the cosine of 30 degrees is the square root of 3 over 2. So to solve this problem, we can simply multiply both sides by 4. So let's put a 4 here and a 4 here. And we notice that those 4's on the left side will cancel. We get v is equal to for the square root of 3 over 2. And we can reduce that to be 2 the square root of 3. And you'll notice it's the same answer. So it really doesn't matter whether we use cosine or sine. Let's do a problem with the 45, 45, 90 right triangle. You see one here. In order to solve for, let's say, v, we can certainly say that the sine of 45 is equal to the opposite side 4 over the hypotenuse v. Notice I'm using this 45-degree angle to use the sine of 45 degrees. And we know that the sine of 45 degrees, do you remember what it is? Why don't we just, sine of 45 degrees is 1 over the square root of 2. And now, once again, the easiest thing to do would be to cross multiply. So we get v is equal to 4 the square root of 2. And that's our value for v. So let's put that here. 4 the square root of 2. In order to find u, once again, we could use Pythagorean theorem. But instead we use some trig. And so we could say the tangent of this 45-degree angle is equal to the opposite side over 4. And we know the tan of 45, if you're not sure what it is, we could go back up here and take a look. And we notice the tan of 45 is 1. So we'll come back down. And let's do that. That's equal to 1. Well, that should be fairly easy. If we multiply both sides by 4, these 4's cancel, and we get u is equal to 4. And now we have found u, which is 4. V is 4 square root of 2, and we are done. And now it's your turn to find the exact length of each missing side without using a calculator. Good luck, and see you again next time.